Awesome. Thank you for the introduction, Adrian. Pleasure to be here today. So, a lot of times we provide information about how to use the platform, but it's at sort of a higher level and sort of intro 101 with LandingLens. But there are a lot of power features or features that power users ultimately include in their release processes for working with the deep learning models. So that's what we'll walk through today as far as what that checklist could look like, what the components are from LandingLens that service that. But the demo itself will focus on how those features are actually used, and it's actually quite a bit to get through. So I'll keep the pace, relatively quick, just so that you can see all of these capabilities. Therefore, so we can have time ultimately for the Q&A. And I'm just going to get rid of my video now so we can focus on the content. So here's a checklist ultimately to think about your own model development process as you start your computer vision application within your organization or potentially your own research project. It's important very much to define what you're trying to do at the beginning. A lot of times, we work with organizations who don't have a clear understanding of what the goals might be for success when they would get to the end of a completed, trained, and ultimately deployed model. So does that success look like saving human time, making them more efficient? Is it about the actual model accuracy itself? Those are all questions to ask as you start to frame up and start your journey towards release. And of course, the data collection is always critical, and a lot of times that can also involve setting up image acquisition systems, which can be a long pole in the tent and potentially quite expensive. But getting that diverse and representative data set is really valuable, and making sure that there's enough data there that you're able to set within the platform using custom training, validation, dev, and then potentially a separate holdout set that we often refer to as sort of the golden standard, and that the data that you have, you ultimately are very confident, because we follow a data-centric approach here at LandingAI to make sure that what you're putting into the model is a pristine sort of understanding from your subject matter experts. And we'll walk through how you can actually set up a labeling agreement task among different SMEs within your organization and use that as a benchmark. A lot of times coming to these types of applications, there's not really an understanding of what accuracy might be from a human perspective. So this can be one tool in your toolkit to ultimately understand that. And within the platform itself, obviously there's a lot around model development that we've optimized. And so there's a default training option that splits the data randomly between training and dev and performs base resizes for different model input types. So if you're looking at classification, for example, it's a standard 512 by 512. And so you might want to consider, based on your own individual use case, if given that image, you aren't losing resolution, because you really would like at least 5 to 10 pixels of objects you want to identify within those images. If the resize then makes that too small, you might want to adjust and perform some resize scaling in your custom training. And all of that's configurable right within the platform. And looking at data augmentation techniques, we apply some standard ones, but in case the data set you have might be smaller to start, you can increase that diversity there. So all straightforward and not really requiring a data science heavy background. You can perform these base data science best practices right within LandingLens, and I'll show you that in the demonstration walkthrough workshop style today. And then you may also want to consider customization around your model and potentially the number of times your model is going through a learning cycle. So we we benchmark available state-of-the-art models and perform our own optimizations on them and include them in the platform. And you'll actually see where they're pulled from an open source perspective in their naming convention, and actually the number of million of parameters that sort of base model or backbone is available to you to customize in the platform. And sometimes whether you're trying to eke out higher accuracy or perhaps higher throughput, you might adjust the sizing of that model and have a beefier or less beefy backbone there. The default mode always sets a sort of lower learning cycle. If you go through an initial hit the easy button in the platform training curve, you may see the sort of learning cycle go up and down and not quite get to the performance level you'd expect. And so you can customize and add additional cycles to see if showing the images to the model additional times might help improve the overall performance. But always be careful there, because we don't ultimately want to overfit and have the models too deep in their understanding of a very specific set of data. And we'll also make sure that we walk through, as I mentioned, we do a standard 80-20 when you hit the default training option in the platform, but there's a lot of value in also including a test split. And usually the best practice is sort of a 70-20-10, but you might have different sort of requirements or data just available. And then additionally, especially as you consider model versioning, as you get more data and grow your data set, you may want to consider, sorry, my slide skipped ahead. You may want to consider adding a separate evaluation set, and we'll walk through that in the platform. It's very straightforward to set up the different test splits and actually see the performance across different model versions. So that is definitely a best practice from a model ops management perspective. In addition, testing in the deployed environment, you can easily test examples that you may have in separate holdout sets, or perhaps from your golden data set in the environment with which you plan to run the model. So whether that's Docker, LandingEdge, or through the cloud, just making sure that you're getting the results you expect in the sort of timing that you expect, and that the model is meeting your performance criteria that you established at the outset, if that is part of your criteria for success. And then, of course, looking at overall model versioning, the great thing about the LandingLens platform is that every time you train the model, we automatically capture a snapshot of all of the data that's used in that training, and allow you to add sort of custom notes in the titling of that snapshot. And it also includes all of the trained settings that are being used for that particular version of the model. So we understand how many epic cycles it went through, what backbone was used. All of that is just readily available directly in LandingLens. So that makes the versioning a lot easier. And so from an audit perspective, that can be really valuable to different organizations. And I see that as a valuable piece of the platform specifically for the enterprise. And of course, deployment, once you actually have tested in sort of the environment you plan to, you then of course need to place it in a production environment and consider scale, latency, and security. So there may be factors like retry logics if you're working with cloud inference, given a certain response from the platform, that you adjust, maybe in your tests for the actual scale of production environment. And then just ensuring that the performance is consistent over time, which is great also for the continuous improvement in the platform. There's a lot of options to allow inferenced images to be passed back to LandingLens for review, to include if there are edge cases that are newly encountered in sort of a continuous improvement or human in the loop feedback process within the platform itself. But it's also easy just to bring those images in directly from the data upload page and just gather feedback from those that might be on a plant or operating floor to understand what they see as potential outliers and gather data to help improve that model over time. But this is a pretty comprehensive list. There's obviously customizations that you'd probably do per project for your own organization, but it's a good start, and it especially focuses on some of the differentiating MLOps capabilities within LandingLens. Sorry. And then just a reminder, the different options for deployment. We offer cloud deployment, so we manage sort of the infrastructure and resourcing to submit images and receive a JSON payload back about the what might actually be in that image based on the models you've trained. We offer edge deployment with our Landing Edge application. This has configuration for inspection points that can communicate with industrial cameras and industrial PCs using PLC logic for those real-time decisions. So it's great to have a UI wrapped around sort of our model process to allow for pre-processing and post-processing. And I'll show you that sort of briefly at the very end of the demonstration today. And we also offer container deployment with Docker. So that's really great for programmatically deploying models in potentially your own current setup where you may have an ML pipeline that's already existing. So just at a high level, when we think about the end of the day, where these models ultimately live, those are the three options. And so now we'll actually move to the demonstration. So we'll take a look at the label agreement capability, which at the start of any project is a great exercise. Even if you don't use those labels for training and you train it yourself, it's good to get a benchmark of how much the humans agree on your particular application. We'll take a look at some of the custom training capabilities, how to leverage the evaluation sets for model comparison. And then we'll look at actually two different deployment options, running cloud inference, and then also a simple setup configuration within Landing Edge. So the data set that we're using today is publicly available from kaggle.com. I will see if I can actually paste this link in the chat. But otherwise, you should be able to just go to Kaggle and search casting product for images and see this very comprehensive, it's quite a large set of data. And so we can do a lot of interesting things with it. The main issue with this data set is that the images are quite small. So in an actual production environment, I'm not sure that ultimately this would be sufficient for the type of inspection ultimately needed, but it is very sort of clean image focused in sort of one scene of view on the physical metal casts themselves. So feel free to do your own tests or sort of follow along with me ultimately in the platform. So here I've loaded a set of 30 images in the platform. Actually, I think there's 40 and I've labeled some of them. And what I can actually do with these images that are unlabeled is create a labeling task. So if I'm working with certain subject matter experts, I'm just going to select 10 here. And obviously I can use my filters to then select all and make this process a little faster. So that's always great as well. But then I can create that labeling task and give it ultimately a name. And then if I want to really see the agreement between individuals and I have two subject matter experts that are going to work on it, then I would set that number to 2. Sorry. And now I can see those two users there and the number of distinctive labels. So I create the task, and then that user actually sees the task populate here, and then they can start performing the labeling. So it's the same as sort of interfacing with the platform in the sort of build section, but just slightly different. So I would just go through this process and submit all of my assigned labels here. And so would my counterpart working as a subject matter expert. I just hit that submit button. And when that's ultimately done, typically you'd have a sort of third person in review of the overall labels. So we can see that 2 are required here. Both assignees, Chung and myself, completed the tasks. So now ultimately we can review. And we can see here, if we're targeting a agreement threshold, do we actually meet any of it here? And it doesn't seem so. So I think this will probably be fairly common across the enterprise that, some users identify more or are more careful in how they label. So it's up to you when you start looking through this, what you decide to accept. But the other good thing to note is that you can use this information to help encourage agreement among your subject matter experts around a label book or a label guide, so that everyone is focused on understanding the same thing. And this obviously is a great reinforcer for the current process that you're trying to help optimize or partially automate today. So you can add that image, of course, the defect there, add the media, and then you can see the label book here offering that capability to provide labeling instructions. So you can add new images to this direct from your own computer or from your actual set of data that you've already decided that you're going to be using for training. You can annotate that and then provide information and media notes for entire group on how ultimately it should be used. So this is great for, again, building consensus around a specific use case or application, and also understanding where your teammates are disagreeing and, coming together in the potential view of the overall. So there's somewhere there's like higher agreement. And you can see that's a little bit more where it's a cleaner sort of image of the defect itself. And this might also be an indicator of the project type itself. For example, if this was a segmentation application, there'd probably be a lot more precision in how defects are being labeled. And there'd probably be, you would think, more agreement around those being included within the platform. So that's a high-level review of how to use label agreement within the platform. So now what we'll actually do is look at the same use case, but with a classification model and how we can optimize that with some custom training. So here you can see in this example, we have 180 images, roughly equal distribution of defective and good. And we've done that automatic 80-20 split where the model is learning primarily on these sets of images. And on the 20% here, it's sort of like an open book test. So the model is still learning some of the features of the images while it's also testing itself. So the good thing to do would be to add an additional test split to this model. And we can do that easily with our custom training. But I want to showcase here just the capabilities that here, those automatic snapshots of the initial standard training that was performed. I can see all of the information about that. So, there's 15 learning cycles. It's using the smaller backbone that's available for this model type. And we can see the actual data snapshot itself of what was used, 100 images, 100 of those were actually labeled. And I can even download this as a CSV or work with it additionally in the snapshot page. So this can be great if you decide, hey, I want to take this particular example and test object detection with it. I can create a new project. Or if you introduce probably some errors that you didn't necessarily want, you can revert to the previous version from your overall data set, and you'll actually be able to see that update and reflect in the browser here. So a lot of opportunity for working with different versions of your model really rapidly and easily here in the platform. So that's just some information there about the versioning. Overall, we mentioned here that this is an 80-20 test split and for train and dev, and we want to introduce that 10% of training data. So what actually I'm going to do is organize and sort by sort of random and filter for, we'll do defective first. And then, so 18 is, 10% of 180. So that's sort of 9 across each type. So I'm going to set the split for these images. You can also set the split on upload, but a lot of times with classification, the upload process is used to assign the label because they can be organized in folder. So now that has been set as the test split. So I'll do the same thing for the ground truth labels being good. And I will sort again, just making sure that it's on random there. So again, we'll set that as the test split. And now when we go to do a custom training here, we'll see, oops, looks like the last one didn't save. Let's go back and do that one more time. I might just be moving too fast. And this is a great practice to always do because the model is not learning any additional features from the images on a test split. Okay. Well, you can adjust that. So somehow I didn't click appropriately, but we can see that we're starting to move in the direction of setting these sort of custom splits. So I'm going to hit the next button here, and now we see all of the customizations that can be done with the model itself. So here, the default value for classification epic cycles is 15. So this is guessing maybe we want to test increasing that number. So I'll leave that as is. But our performance is pretty good. So I'd like to trade sort of speed for accuracy. So I'm going to select the smaller 16 million parameter model backbone here. And then the other thing I'm going to do is we know our images are pretty small. They're actually 300 by 300. So what I'm going to do is adjust the resize actually down. And with the new pricing that has come into the platform, this can actually help your credits go further in the platform as well. We can see that the train will cost a certain percentage here, but the prediction is actually, it's a little, this is 180 images. It's a little under a credit per image, but it's well under, it's almost a quarter of a credit per prediction based on just the image size here alone. And then we usually just include these standard augmentations. It's often good to sort of preview what that effect looks like, just to make sure that it makes sense for your use case. And these, I don't actually think it does. So I'm just going to remove them from my particular model. And then I'll hit the train button here. But these are all important considerations for anyone. I was working and just looking at this image. Let me pull it up here. So this is a different sort of version of a metal cast with a lot more sort of complication and complexity. And you can see there's sort of a defect here that's very small. And we, again, want to make sure that we're always capturing at least 5 to 10 pixels of what we want to identify, so that the model is getting enough pixel space to actually understand what it's looking for, and just the actual image of size of this one is much larger. So it's 1024 by 1024. We could obviously probably crop that down a little bit to get rid of some of the background. But again, these are considerations you may make as you look at customizing your overall model. So I would hit that train button here. Of course, it's confirming the amount available, and it's starting to perform that training, doing all of the things in the background that are ultimately important. I'm going to let that run while I go ahead and set up some additional evaluation sets here. So we can see that this model has started training. My initial model had 100% and 95%, and then a little bit of improvement in the development split with additional images. And these are both the default configuration, and you can hover over to see what that was from the platform perspective. But now I'd actually like to, well, we'll see the test images once that model actually completes running. But I'd like to add an additional evaluation set. And what I want to do to actually do that is bring those images into the platform. So I will go to my upload. Finding my folder directory. So we can see these are defect and good. And I'm just going to add a tag here to say golden, because this will make it really easy for me to filter to create a specific snapshot of these images. So it loaded those really rapidly. And now what I can do is filter on that particular tag, and then select all and save as a snapshot. And here, I think it's nice to have the name and time included, but the important piece about this is these are edge cases that I always want to make sure the model correctly identifies as we iterate and add new data. So I will save that particular snapshot. And now when I come back to my models screen, I can add an evaluation set here. So these separate images will always be added, and I can review what that performance actually is. And it takes a little bit just to incorporate, but you can also add additional ones here. So it's quite complex. And what's great about it is you can actually take a look at the data here and analyze the performance sort of by class. And again, always see that training information available just within clicks in the platform. So only one misclassification here. It identified this as a defect. has slightly lower confidence. And I think, I can see why, given some of the other images, why this might be incorrect. So, but this is an edge case I want to make sure I'm always capturing. So we can look at adding more data to help optimize for this. So this is one way to use the model comparison and evaluation sets within the platform. Obviously, this is a more straightforward and simple use case with just 5 examples. I've seen customers with many, many more examples in their sort of golden data set. So it's ultimately up to you. So the final piece is just we want to show ultimately how you can deploy these models. So again, we have quite a few different options here. Here, I've made an endpoint available for cloud. And then we can also download this model for LandingEdge. And with our new updated packaging, you have to make sure you activate the project first. And I've actually already done this. And then if you're leveraging Docker, of course, you would use the model ID. But once you put the model in sort of a deploy state, then you're able to download LandingEdge as necessary, or work with the webinar or the endpoint itself in cloud. So you can see what the prediction cost is here. This was done with the default training, so we see it's 1 credit per image. And so if we actually bring that into our example workspace here, where we have the API prediction inference endpoint set up with some headers that include our API key, then we can actually pass images from our local machine. I tested a defect one. Let's see if it actually works for a good image and perform that request here. And this is a good sort of one of those final tests to see the timing of the response and all of the pieces of information that you receive from that JSON payload. And it is correct and that it's identified as good with a high 99% confidence. And I also can see the model ID here as a reference here for my own auditing process. The other option I mentioned is LandingEdge. So this is a previous version of our LandingEdge application that works on a Mac machine, because that is ultimately what I use. But it works the same as it always has, except now you don't have to include a license key. So you can just download that direct when you log into LandingLens and you've activated your project. And you can activate it from the specific project or in a broader place in the platform. But here I've set up to actually watch a specific folder instead of connect to an industrial camera or use a web API to interact. And I'm going to start the inspection myself. I've actually loaded the model just directly from the bundle. So that's something that's really nice, because within the platform, I'm just going to pull up my downloads. You can see it's just a bundle that's available here. And I don't need to do anything or read the individual files that are within there. If you are familiar with Onyx, though, and you're trying to port it into other systems outside of Docker or LandingEdge, you would want to unbundle this and use that Onyx file. But then I'm going to save the images here and save them locally to that specific folder. So I hit save configuration and run now. And then ultimately on my desktop, here I have my folder watcher. And what I'm going to do from this small data set is just copy. So this would hopefully be done in a programmatically way, where they're coming into this folder watcher from another system. But what you'll see is that as that happens, now they're being processed one by one with the result here. And then I also get the image and the JSON payload that I can use to create spreadsheets and information about the prediction. So here I see that it was identified as a defect with a 99% confidence score. So those are two high-level deployment options from the variety of MLOps best practices we took a look at in the platform today. And I see there's quite a few questions in the chat. So we'll move to the Q&A portion of the webinar.
Excellent, excellent presentation. Everyone, thank you for those questions. Keep them coming. This is a live Q&A, so let's kick off with our first one. Let me go ahead and do this for this particular user. Let's see, give me 1 second. Let's see here. Okay. Oh, wait, what's going on here? Okay. Go ahead. Paul, go ahead and ask your question. Paul, are you able to ask your question? Paul enabled you to talk, so you should be able to. Just give another few seconds here. Okay, let me go to the next question. Bear with me 1 second here.
Yep.
Is there a way to detect color variation in skin color of a person from her pics or the pics?
So it's all about ultimately what you visually can see and then associate with a label or class. So if you want to train a model to do that and it's visual in a way you can sort of understand, then you should be able to create a model to do that. I'm not sure at what pixel level you're looking to identify this variation, if it's more broad areas that maybe object detection or segmentation might accomplish, or if it's sort of more across the whole person. But it's definitely a possible use case. I'd be interested to understand how it would be used in day-to-day life, because that's very interesting.
For the user that asked their question, if you'd like to raise your hand, I can enable talking. So I will go to the next question, but feel free to raise your hand if you'd like to chat with Erica live. And let's go to the next one. What would be the limitations of the platform if we want to implement this to a large manufacturer outside the United States?
So I would say there's not necessarily a limitation of the platform itself. What we're exploring currently when it comes to large manufacturers is following sort of compliance and overall security processes. Some of those are much more strict. We do have our very large manufacturers already using the current state of LandingLens, which is a multi-tenant AWS hosted solution. Because we also offer LandingEdge, which is air-gapped and can be sort of completely offline, there's no concern after the initial model is developed about loading data and that data sensitivity on the cloud with AWS. What we're exploring for the future and as part of our roadmap is ultimately providing the LandingLens platform within customers' own virtual private clouds. So this helps remove some of that data sensitivity restriction. And I believe the current target for that will be sort of end of year for the initial beta of the first type of VPC. So that's just something to consider. And we would definitely love to have a conversation about what kind of applications and what manufacturer, because we do work with a lot already. And many of our use cases are around defect detection. So that QA process, there's a lot of value in what LandingLens offers. And hopefully that answers your question. That's the biggest limitation I see. Sometimes there's considerations around image pre-processing. So we've worked with manufacturers that are using X-ray machines that are in DICOM format. This could be medical device manufacturing or, other types of manufacturing more general. And so there's some pre-processing to get that in the sort of desired ping format within the platform. And then depending on the image size, we support up to 36 megapixels for running sort of inference and training. And so sometimes, depending on the defect you're trying to identify, there may not be enough resolution in such a large image. So that's something to also think about. And then just understanding from a use case perspective, the speed and throughput requirements. Usually that means that we'd be deploying at the edge with a certain amount of computational footprint that would accomplish, high throughput, less than 100 millisecond per inference for these manufacturers. But I haven't seen a limitation ultimately, but those are definitely considerations.
Thank you. Liz, I enabled you to talk, so you should be able to ask your question if you want to go ahead and ask your question of Erica.
Okay, yeah, thank you very much. Can you hear me properly over there?
Yep.
Yes.
Sure can.
Yeah, so first of all, I want to thank you, Erica, for the presentation. Awesome thing. The reason why I ask is because over here outside of the US and Canada, we have basically big manufacturers as of our clients they have basically big initiatives into like image recognition, especially for quality assurance process when they want to use this to detect defects on many of their products that they're producing. So I wanted to know basically like what's basically the process if we want to work with you guys to bring it over here in Canada? Like, do we use your software in sort of a like license agreement, or do we work with you directly?
Yeah, we have a variety of options and an extensive partner network if you're looking to sort of provide our capabilities to customers that you already work with. And so in that case, you'd probably want to talk with our partner lead, Carl Lewis, and just get a sense of your footprint and what you're trying to do. And we have a lot of different types of packages we can offer for sort of more of an OEM distribution, or if you're doing it sort of as a consultancy for the end client, we can shape that in different ways just to fit your need. So we'll definitely take an action to reach out to you and connect you with our sort of partner program.
Perfect. Thank you very much. I definitely will be in touch. Thank you.
Great.
Okay, our next question. I have a big need in quality assurance process.
Sorry, it's my question. I did like in a two-way. I'm sorry.
Oh, no worries. Did you want to? Did Erica answer that question for you?
No, it's okay. Like I'll just like keep in touch with you guys, and we can work it out of the webinar or like offline.
Okay, great. Let's see. Our next question is testing certificates provided by the model is acceptable by production industry? Do you want to reread that? Does that make sense, Erica?
Yeah, I'm not sure what you're looking for a testing certificate. I know sometimes there's, especially with manufacturing, there's a requirement for repeatable results from AI to make sure the model would state the same thing every time it showed the same sort of circumstance or environment. So we can assist with making sure those tests are accomplished. And then I'm not sure if that then would allow for a certificate. But we have many use cases in production across a variety of different industries. So some of the biggest and earliest adopters are in manufacturing, but also in the life science community. And then we're seeing sort of emergence in retail as well. But production use cases with very high inference volume, both cloud and edge at a variety of global customers using LandingLens.
Excellent. If that user would like to raise their hand to ask the question again or more expand on it, feel free to, and I'll enable you to talk. Erica, if we could go through a couple slides here, let me take over. Thank you, everybody, for joining today's conversation. Erica, if you go back to your slides again, that'd be great. Keep asking questions until we end, because we will take those questions live. Highly encourage everyone to continue to sign up for LandingLens if you haven't already. We have an entire support group that from our community to our support engineers to built-in chat via Pendo, or feel free to ping us on our website via Intercom. We're here to help. Get certified, get those certifications. It's a great program. It helps you gain additional knowledge to make sure your CV project is successful. And if you go to the next slide, Erica. For everyone on the call, we highly encourage you to take advantage of our no-cost consulting. It's just really an opportunity for you to share what you're looking to do, and we'll give you feedback on where we can help you, share some best practices, and then figure out what makes steps for next step, great for next steps. You'll see the URL down there. Feel free to take a snapshot of that. And let's see, with that, if there's no more questions, actually we have more questions here. Let me go through here. Okay. Erica, how would you integrate LandingAI with a camera system? Does it support specific camera types?
Yes, so we are GennyCam compliant. So I'd be interested to understand what type of cameras you're looking at. We really consider ourselves overall to be camera agnostic because, for example, you saw me set up LandingEdge with a folder watcher. Even if the camera system itself is more of a closed loop, you can often always output those images to a specific folder that then LandingEdge is watching and running inference on. And the nice thing about that is that, there's no programming necessarily required, but you are able to set up sort of sophisticated interaction with PLC logic within the platform with some OPC UA tags. So that's also an option. So yeah, if you want to clarify more, like potentially the type of camera, I mean, we see a wide range. Some use cases are not necessarily requiring a certain level of image resolution, and so it's a simple like webcam, and they're doing cloud inferencing. But then, there's all sorts of range of industrial cameras that connect either with LandingEdge or in customer sort of own discrete environments.
Excellent. And then next question, can you do model training on edge?
So today we do not offer model training at the edge. This is an area of exploration that we will look to see if we can fold into different offerings and different sort of variations of what is today sort of LandingLens as a multi-tenant and then deployment at the edge. We are and have announced with Snowflake as a partner our first native app. So if you're already a Snowflake customer, the beta will be launched in June, and you can actually run and train models with that native application in your Snowflake environment.
Excellent. Next question. Are you seeing use cases in generating synthetic data for training models?
Yes. I would say because, for example, sometimes there's just lack of data to represent use cases. So I've definitely seen models developed within LandingLens and for different applications that use synthetic data. I think it depends on how that data is created on the overall performance when you translate that from synthetic to the real world. I do think it can be a very good starting point. So it's always a worthwhile consideration, but would likely require more fine tuning and adjusting over time.
Thank you everyone for joining us today. I hope this was a useful session. I hope it was productive. And again, we are here to help. So take full advantage of our follow-ups, emails tomorrow, share the replay with your colleagues. And if you have other organizations or groups that you belong to that you think that we should be promoting what we're doing to, please share that information with us. We would like to get in front of those user groups as well. Thank you again. Have a great Wednesday.